Hello, welcome to our class prep for section 6.10 on chi-squared tests in RStudio. So this is really different. So hopefully all the other stuff kind of after you turned in your homework or after you've been working on the homework that's due next time is starting to feel pretty repetitive and you're getting good at it, I hope. All right, so this is a totally different situation. It's for looking at categorical variables like the color of your eyes, or your college major, or how does the type of exercise you do affect the major you have, or right. So like notice like categorical variables. So that's what we want to look at. We're going to look at two different tests. They're called chi-squared tests, not chi-squared, chi-squared. All right, that's because of the variable we use. And they're not too hard to do, okay? So we're just going to be doing them in RStudio generally, and we'll look a little bit at the math of it when we get to class, all right? Okay, so the first test that we're going to do is called a goodness of fit test. And kind of sounds like kind of undergarment, I think, but it's not. It's a test that is sort of about something called multinomial. So what I want you to remember is that, whoops, I don't know why I highlighted failure. Recall that like a Bernoulli trial was something where you get like two categories. We call them success and failure. And they had probabilities P and 1 minus P. Well, so now what we're going to have is multinomial trials instead of Bernoulli trials, and there's K categories. So we call those categories 1, 2, 3, 4, all the way up to K, and their probabilities are P1 through PK. So for example, of multinomial experiments would be categories when you roll a fair die, categories of 1, 2 through 6, and with each have probability 1/6. So P sub 1 would be 1/6, P sub 2 is 1/6, and so on. Or we're going to see an example with MLB pitchers who reportedly throw fastballs, sliders, curveballs, and changeups with probabilities 59%, 17%, 13%, and 11%. All right, so notice those are totally different situations, but the whole point is these are categorical data, right? So the data is which of these numbers was it, right? And what was the kind of pitch that was thrown in the trial. Okay, so let's work through this example, okay? So this will kind of serve us to like kind of get you started understanding what's going on a little bit, hopefully understanding some of the logic behind this kind of test. So, so MLB, right? So these are Major League Baseball pitchers. They throw different kinds of pitches, and I don't really care if you know anything about baseball or not. All right, but they literally throw these different things that do these different kinds of balls when they pitch, right? That do different things, and they're like generally they throw these fastballs. So 59% of the time they throw fastballs reportedly, okay. And sliders 17% of the time, 13% and 11% for curveballs and changeups. The 2019 Los Angeles Dodgers, however, had the following pitch counts for their starting pitchers. Their fastballs were over 3,000, their sliders were 545, their curveballs were 510, and their changeups were 99. Okay, and our question is there evidence that the Dodgers really use a different proportion of pitches than what's typical for the MLB? Okay, so that's the kind of question we might want to ask here is like, are we different than what is expected, okay, in a population? So that's exactly what this question is. We're wondering if the Dodgers data fits what we expect. And so we're trying to measure how good their data fits. So first of all, the hypotheses are really easy to state. All right, so this is something that you probably want, well, right, so the way we state the hypotheses are, and you'll see this in your book when you look at the notes, is H0 is just the list of probabilities that we expect to see. And then the way I say H1 is just not. All right. And all that means is at least one of these is not as it's stated. Okay. So we have, this was what was reported, right? That fastball should be 59%, slider should be 17%, changeup should be 13%, and so on. All right. And H1 is the opposite. At least one of them is not correct. Okay, so our step one, state the hypotheses, right? They look different. Step two, put together data into vectors and calculate a test statistic in RStudio. Okay, so recall the Dodgers had fastballs 3,135, sliders 545, curveballs, right? That's what we had for our data. The data is really weird, right? It's like a vector. Okay, so here's what we do for the chi-square test. This is the, this is literally what you're going to do, right, in RStudio when you type things, right? So you're going to have chi-square test, chi-sq dot test is the test, just like t dot test, parentheses. So now, remember these C's are ways to express vectors, okay? And so what we have is a sample vector, and what I want you to notice is the sample vector, it's not written as proportions or percentages. It's written as frequencies. So notice this one is the frequencies. How many? Not percentages. So when you write this in your notes, make a note to yourself that those are frequencies, and notice these are written as proportions, numbers between 0 and 1, proportions. All right, so there, so you have these two things. So the code, I don't know, I got a comment. Okay, so the code is chi-square test. The first one is the frequencies we see in our sample. The second one is P equals the population proportions. And so R will make a comparison between this 59% and that 31.35 and so on. And when you run it, this is what will pop up. Chi-square test for given probabilities. Okay, and notice the test statistic is called, really that looks like x squared, but it's really a chi-squared. Chi-squared looks like this. Chi-squared. Well, usually it would have a square on it. Okay, so the test statistic is a chi-squared test statistic. And notice it's like 400 and something, right? Chi-squared is different than normal. It won't be numbers like -3 to 3, okay? But something in the hundreds is huge, okay? So things that are small in chi-squared might be like smaller than 8 or something like that. And our p-value is very small, approximately 0. So we should reject the null hypothesis. So notice all those basics about hypothesis testing, they still apply. So we reject, well, we'll go on to the next page and we'll do this. Okay, so here's the chi-square test. Here I wrote it with the right symbol, and the p-value is approximately 0. It's fine for something that size, just say it's about 0. Step 3, the p-value is less than 0.05. We reject H0 and conclude H1, right? So you've been doing this. This means the LA Dodgers starting pitchers do not use pitch proportions typical to the whole MLB. So they're a little different. Okay, so remember, we reject H0, we conclude not. These proportions are different for the LA Dodgers. Notice it doesn't tell us where the difference is. It just says there is a difference between their proportions and the proportions for the larger group. So here's some of the things you could fill in your table. You could write or in your notes. I know I wrote this in a table. Your table does not look like this, but not exactly like this, but the goodness of fit test, right? The hypotheses are that the probabilities are certain numbers versus H1 not. Here's one of the things you need to know is that all sample frequencies need to be at least 5 for the method to be appropriate. Otherwise, the method's just approximate. Okay, it doesn't make it like horrible. It's just an approximation. But I mean, if you have more than 5 in each of the categories, like if we needed to have at least 5 pitches in each of those categories for this really to work, and then there's the code that you could put in your table, okay? So you can pause the video and put that in there. All right, so the second test, and this is also a chi-squared test, so this is also a chi-squared test, all right? It's a chi-squared test of independence, okay? And this is situations in which we want to know whether one categorical variable affects the occurrence of another categorical variable. So for example, is the result of a die roll dependent on the hair color of the person who rolled the die? I mean, it's ridiculous. I know. I get it. All right. Or is a pitch thrown, like fastballs, sliders, curveballs, changeups, dependent on the pitcher's handedness, left or right-handedness? Okay, so notice, I mean, there's a lot of things like that that you could ask. Okay, is like the kind of housing that a student lives in on campus, is it dependent on their Greek status, right? Is a student's major dependent on whether they're an athlete or not? Right, so notice there's lots of interesting questions, but those are all categorical kinds of variables. And I'm sorry, I know this is really only your example 2, not example 3, but I'm using some slides I made last year. So anyway, but we're just going to go through this example. We're not going to have time to get through the whole thing, but I just want you to at least think through it with me. So this data that I have, it's called survey, and it's in RStudio. So we're going to load this up and we'll be using it some. Okay, and what it is, it's a really cool data set about college students at the University of Adelaide, which is in Australia, in 1999. And it's all this stuff like about health, like smoking and exercise and all these other things. All right, so this one, we'll go through this and I'll give you the steps in class. But we want to know if the smoking habits are independent of exercise habits. Like, you guys can think about it. Like, do people that smoke cigarettes, like, you think like whether you smoke cigarettes or not has an effect on how much you exercise, or how much you exercise, does it have effect on whether you smoke cigarettes or not? All right. I mean, it's a decent question. All right. What we're going to do is we have to create a table, and I just want to look at this table with you before we go. Sorry, I got flipped around. Okay, so this table we're going to make in class. So this table RStudio makes for you. Okay, and what this is, you can see that the rows of the table, heavy, never, occasionally, regular, this is exercise. All right, so this is whether you, I think this is the exercise one. Are you, oh, maybe that's smoking. All right, so we'll have to find out. Oh wait, it says rows show smoking. This is smoking. The columns show exercise. Oh yeah, because it's always rows columns in a table thing. This is exercise. Okay, so what do you guys think when you just look at it? So this is summarizing their data. You can tell it's a pretty big data set. One thing I want you to note is there's a lot of things that aren't fives, right? Like the number of heavy smokers who do no exercise is only one of them, right? And the number of regular smokers who have no exercise is only one also. So this is only going to be an approximation when we do it. And if you're really trying to prove something, you'd want to make sure that this would work for us. We're going to talk about ways to do that. Let's do that. We're not going to get through this table anyway. One thing you can do to improve things is you combine some of the rows or columns, okay? So what you do is do some adding. Because notice, if I made like none and some, if I added those, at least I'll get up to 4. And if I added these two, I'd get up to 8. And this test would be better. So I would actually make a new table, okay? I might make a new table that would help me do this thing by adding these and combining things to make it something that reaches the 5 threshold, okay? And so what we want to know is, using this table, we're going to put a table together in R and then use that table to test whether those are independent, okay? So notice it's independent or not again. All right, I'll see you.